Welcome to Reflect with Ed Fassio. Get ready to experience one of the world's first 100% digitally generated podcasts, where we take a step back, dive deep, and strive to learn new things. Join us as we unpack thought-provoking ideas, personal reflections, and inspiring stories to help you stay in the know. Reflect is brought to you by the minds at ByteBrain and powered by emerging technologies from Google, HeyGen, OpenAI, and 11 Labs. Thanks for tuning in. Now, relax and prepare to reflect.
Welcome to Reflect, one of the world's first 100% AI-generated podcasts. So I want you to imagine this scenario.
Okay, lay it on me.
It's a Tuesday afternoon. Your company's primary checkout system just goes down.
Oh, the classic nightmare.
Exactly. You are losing, I don't know, $10,000 a minute. So you pull up the recent code commits, right? And the code looks absolutely flawless.
I mean, it always does these days.
Right. The syntax is beautiful. The variables are, perfectly named. It is a masterpiece of software engineering. But, and here's the kicker, it is fundamentally invisibly wrong.
Yeah.
It's processing absolute garbage because an AI just confidently hallucinated a business logic rule and your exhausted human engineers just waved it through.
And that right there is the terrifying reality hiding behind all these incredibly optimistic quarterly slide decks we're seeing right now.
Yeah, the AI coding gold rush.
Exactly. On paper, it is a total dream for you. You describe what you want, the AI writes the code, your backlog shrinks to zero, and you ship instantly.
But on the front lines.
On the front lines, the systems are just suffering from this subtle, hellish drift.
It is scaring the hell out of engineering leadership right now. So for today's deep dive, we are pulling from a really eye-opening piece published on March 20, 2026 by Ed Fassio.
It's a great piece.
It really is. And our mission here today is to answer the million-dollar question. How do you, the listener, the leader, the person whose neck is actually on the line, how do you harness the badass speed of AI without letting system drift tear your product apart?
Well, to even have that conversation, we kind of need to recalibrate our vocabulary.
Right, because the words mean different things now.
Yeah. Fassio points out 5 specific terms, like 5 scary words that pop up in these discussions, and we shouldn't just define them. We need to understand how AI has completely mutated what these words mean in a modern workflow.
Okay, let's break them down. I mean, I know the traditional definitions, but how is AI actually changing the reality on the ground?
So take the PR, right, the pull request. Historically, this was a peer-to-peer discussion. You proposed some code, and a senior engineer reviewed your logic. Today, a PR is increasingly just a human desperately trying to audit a machine's hallucination.
Oh man, that's so true. What about the stack trace?
Right, so the stack trace is usually the breadcrumb trail showing what the system was doing right before a crash.
The diagnostics.
Exactly. But when an AI tries to fix a bug without grounding itself in your specific architecture, it often it hallucinates its own stack traces.
Wait, really?
Oh, yeah. It sends developers chasing total ghosts.
So the diagnostic tools themselves are becoming unreliable. That's terrifying.
Yeah.
What about deployment and incidents?
Okay, so deployment used to be this highly guarded, almost sacred ceremony. Now it's just the act of pushing unverified, probabilistic machine output to live users at light speed.
Which inevitably leads to the incident.
Bingo. The classic oh shit moment where operations completely halt. Only now, because AI integrates code so rapidly across, dozens of microservices, the blast radius of an incident is infinitely harder to trace.
And I'm guessing that makes the final word, the rollback, a lot harder.
Oh, rolling back AI-generated code is an absolute nightmare. The AI has simultaneously altered 20 different interdependent files, and literally nobody knows which specific line actually triggered the meltdown.
Wow. Okay, so PR, stack trace, deployment, incident, rollback. The vocabulary hasn't changed at all, but the underlying mechanics are just completely different.
Exactly.
Which really exposes the core tension here, right? If an AI is churning through JIRA tickets and generating massive amounts of code, isn't that the literal definition of productivity? I mean, why is there so much panic?
Because activity does not equal progress.
Oh.
There were some really fascinating interviews in the Register recently with the founders of CodeStrap, and they called out this exact illusion.
What did they find?
That organizations are just measuring the wrong things. I mean, they are throwing parties over the sheer volume of code being produced.
Just celebrating the output.
Right, while completely ignoring the fact that this volume vastly outpaces their human capacity to actually verify it.
So they are essentially drowning in their own output. And there's hard data backing up this localized panic too, right?
Hmm.
I'm thinking of the 2025 DORA report from Google.
Yes, the gold standard for measuring developer operations. That report uncovered this massive trust paradox.
Which is what?
Well, despite the universal adoption of these tools across the industry, only 24% of respondents reported having a great deal of trust in AI outputs.
24%. That is a remarkably dismal number for a technology that is supposedly, revolutionizing the entire
It
industry.
really is.
But I want to be clear for you listening, this isn't Luddite paranoia. This is trauma from the trenches.
Right.
Developers don't distrust AI because they're afraid of Skynet or the Terminator.
Right. No.
They distrust it because they actually understand the underlying mechanism of a large language model. LLMs are just probabilistic token predictors.
Exactly. They are not deterministic logic engines.
No. They don't think about how your company's bespoke payment gateway functions. They just predict the next piece of syntax that mathematically looks like a correct payment gateway.
And that mechanism is exactly why the code is so dangerous.
How so?
Well, if an AI writes obviously terrible code, code missing commas or brackets, it won't compile. The system just rejects it immediately.
Right, an easy catch.
But the true danger is that probabilistic models excel at writing plausible code.
Plausible code.
Yeah. It looks perfectly formatted, it sounds incredibly confident in the comments, but it contains microscopic flaws in the business logic.
The kind of flaws that a tired human reviewer who is just skimming the PR at 4:00 p.m. on a Friday is going to easily miss.
Exactly.
It's the uncanny valley of software engineering. And when that plausible but hollow code slips into the main branch week after week, you stop building a product and you start accumulating debt. Invisible compounding debt.
And software engineers have always dealt with error debt. The hidden mistakes and accounting shortcuts that pile up until a system inevitably crashes.
Right, tech debt is a tale as old as time.
But Adi Osmani introduced a much more terrifying concept for the AI era, which is comprehension debt.
Comprehension debt. Basically,
Yeah.
the widening gap between the sheer volume of software a company owns and how much of it any living human actually understands.
Precisely. When an AI can generate 10,000 lines of code in a single afternoon, that gap becomes a canyon almost overnight.
Let me put it this way for you listening. Imagine inheriting a 100-story state-of-the-art skyscraper.
Okay, I'm visualizing it.
The lights are on, the elevators are humming. But you slowly realize the plumbing and the electrical grids were built by an automated machine that left zero blueprints.
Oh, wow.
Right now, everything works. But the moment a single pipe bursts on the 40th floor, your entire engineering team is completely paralyzed.
Because they have no idea how it connects.
Exactly. They are terrified to shut off the water main because they have no idea if the AI wired the water main directly into the fire suppression system or like the server cooling loops.
And that paralysis is already happening inside enterprise code bases right now.
Yeah.
When comprehension debt reaches critical mass, the organizational toll is devastating. You see the symptoms everywhere. For example, pull request descriptions become aggressively lazy.
Oh, I've seen this.
Developers stop explaining the architectural intent of a change and just write, AI did it.
The magic box said this was fine, so please just approve it.
Exactly. And because nobody understands the mystery wiring in that skyscraper of yours, when a real incident strikes, the recovery time doubles or triples.
Because you have to figure out the wiring first.
Right. The team has to spend agonizing hours just reverse engineering what the AI was even attempting to do before they can begin to fix the actual bug.
That sounds exhausting.
It is. Eventually, a culture of fear sets in. People stop refactoring. They stop improving the legacy systems. They just build fragile layers on top of the mystery wiring and pray it holds.
You essentially use a hyper-advanced AI to build a digital museum where nobody is allowed to touch the exhibits.
That's a great way to put it.
But eventually, someone has to touch the wiring. I mean, they have to push an update.
Yeah.
And when they get it wrong, you get a massive, very public explosion.
And the stakes are far beyond theoretical at this point.
Yeah.
In March 2026, the Financial Times actually published a report claiming Amazon had to convene a high-level engineering meeting to address recent internal incidents.
Right.
The FT reported these incidents had a high blast radius and allegedly involved Gen AI-assisted changes.
Now, we have to pause here and be completely impartial because Amazon fired back with a very strong public rebuttal to that specific FT piece.
Yes, they did.
They stated the report contained significant inaccuracies, and they aggressively pushed back on the narrative that AI-written code was the root cause of those outages.
And that is a crucial clarification. But, zooming out from that specific corporate dispute, the underlying anxiety across the entire tech sector remains totally valid.
Right. Regardless of who was right in the Amazon case, just the phrase high blast radius is keeping executives awake at night.
Oh, absolutely.
The sheer speed of AI development means a single flawed assumption can cascade through an entire microservice architecture before anyone even notices, which is why companies are frantically trying to tighten the deployment gates.
And nothing motivates a company to tighten those gates faster than a massive security breach.
Oh man, let's talk about the specific nightmare that is giving chief information security officers a collective ulcer: leaked secrets.
Yeah, the Git Guardian 2026 State of Secret Sprawl report provided the hard numbers on this, and they are just staggering.
Lay it on me.
In 2025 alone, they detected over 28.6 million new secrets leaked in public GitHub commits.
To be clear for everyone, in software, a secret is a digital master key. It's an API token, a database password, an encryption key.
Exactly.
And according to the Git Guardian data, leaked secrets in AI-assisted commits are occurring at roughly twice the baseline rate of normal human commits, 2 times the rate.
It's wild. And the reason goes back to the underlying mechanism we discussed earlier.
The probabilistic tokens.
Right. An LLM has no concept of physical world consequences. It doesn't know that an AWS token grants access to your company's actual bank account.
It just sees a pattern.
Yep. It just sees a string of alphanumeric characters that satisfies the syntax requirement of the code it's trying to generate. So it just hard codes the secret directly into the script.
It's literally like building an incredibly fast, highly efficient factory robot. And its only job is to print millions of master keys to your corporate headquarters and mail them to random addresses on the internet.
And simply because nobody specifically programmed the robot to understand what a lock actually is.
Yeah. And when you have automated systems broadcasting your API keys to public repositories at twice the normal rate, you are no longer dealing with a simple coding error.
No. You have crossed into severe operational liability.
Which forces the conversation into an area that engineers historically hate: compliance and ethics.
Oh yeah, AI ethics usually gets a collective eye roll in the dev channel.
Right. People picture a dorm room debate about the trolley problem.
Right.
But in modern software development, ethics is a brutal financial reality.
It really is.
When an AI hallucination leaks customer data or brings down a financial exchange, regulators don't care about the trolley problem. They want to know whose head is actually on the chopping block. So who holds the bag?
Well, Fassio outlines 4 business-friendly non-negotiables for AI ethics in this space.
Okay.
First is accountability. The model hallucinated is not a legal defense.
Good to know.
Yeah, a human signature remains legally responsible for what ships to production. Second is transparency. Engineering teams must be able to document exactly what changed in the code base and why.
Which fights comprehension debt.
Exactly. Third is safety. Your automated verification processes must scale proportionally to match the volume of AI code generation. And fourth is security and privacy.
The guardrails.
Right. Hard guardrails must exist to prevent the exact kind of credential leakage we just talked about.
So the era of move fast and break things is essentially dead when the thing you are breaking is international privacy law.
Very dead.
And the government isn't just sending warning letters anymore.
Now, the regulatory walls are already closing in fast. You have the NIST AI risk management framework providing the theoretical blueprint, but the real teeth are coming from Europe.
The EU AI Act.
Yes, the EU AI Act has turned this into an immediate board-level compliance issue.
Yeah.
And the timeline is extremely aggressive.
What are the dates?
Obligations for general-purpose AI models kick in on August 2, 2025, and broad applicability across the enterprise hits on August 2, 2026.
Meaning the grace period is entirely over.
Yeah.
You cannot treat AI as a fun experimental sandbox anymore. If your software touches a single European citizen, you had to prove you are in complete control of your automated systems.
You really do.
So let's pivot to the cure. We have compounding system drift, massive security vulnerabilities, and regulators holding a literal stopwatch.
It's a lot.
We obviously can't ban AI. I mean, your competitors will just crush you on output alone.
Yeah.
But how do you actually drive this incredibly fast car without hitting a wall?
You implement a workflow that actively distrusts the AI.
Distrusts it. Okay.
Yeah. The market is saturated with fast, predictive coding tools. But tools do not save you from bad habits. A disciplined methodology does.
And what's the methodology?
Fassio highlights Brock's LUTs mode as the gold standard here. It completely abandons the quick prompt mentality and enforces a highly structured loop. Research, plan, build.
Okay, I have to play devil's advocate here.
Go for it.
If I am paying a massive premium for an AI to generate code instantly, and you are telling me I have to force my engineers to stop, research the architecture, write a detailed execution plan, and then build the code in tiny verified increments, doesn't that entirely defeat the purpose?
I hear that a lot.
Right. I mean, I bought a Ferrari for the speed, and you're telling me to drive it like a student driver in a school zone.
Well, look at it this way. You install high-performance brakes on a Ferrari precisely so you can take corners at 120 miles an hour without flying off a cliff.
Okay, that makes sense.
Let's map this disciplined research plan build workflow onto 3 specific real-world scenarios to show how it actually prevents catastrophic slowdowns.
Let's do it. Scenario 1, the production bug.
Okay, it's Tuesday, the checkout is melting down, customers are furious. The temptation is to copy the error message, paste it into the AI and say, fix this right now.
And the AI will eagerly oblige.
Oh, it'll write a patch in seconds that makes the error message disappear. But because it doesn't understand the broader architecture, that quick patch might completely corrupt the downstream database by formatting the time zones incorrectly.
So the symptom is gone, but you've just planted a time bomb for next month's billing cycle.
Exactly. So under the Let's Mode workflow, how does it change? You force the research phase. You use the AI not to write the fix, but to pull the stack traces and map the dependencies. You isolate the exact blast radius. Then you plan a verifiable test to reproduce the bug.
And then?
Only after the human approves that plan do you let the AI build the smallest, most isolated fix possible. It feels slower in minute 1, but it saves you a 3-day database restoration next month.
I totally see the value there.
Yeah.
What about scenario 2, the massive legacy migration?
Migrating an old application to a new framework is where AI really shines as a bulk generator. I mean, it can translate 10,000 lines of code in minutes. But it's also the ultimate chaos machine. If you let it perform a big bang migration all at once, the subtle translation errors will cross-contaminate the entire system.
And you'll drown in comprehension debt immediately because no human can audit 10,000 newly generated lines of code.
Exactly the issue. So the discipline workflow demands staging. You research the oldest, most decoupled module first. You plan a step-by-step rollout. You build the migration in small, distinct increments.
You catch the errors early?
Right. You catch the AI's hallucinated variables in a low-stakes environment, rather than discovering them when the entire platform goes live.
That brings us to scenario 3, which I think is honestly the most dangerous. The integration change.
Oh, absolutely.
This is when your code base has to shake hands with a third-party partner, like a payment gateway, an inventory supplier, or an identity provider.
And if an AI hallucinates the logic for an internal button, it's annoying. But if an AI hallucinates the logic for a partner integration, you are violating service-level agreements and breaching legal contracts.
Wow.
And the terrifying part is that integration failures rarely result in a spectacular crash. They fail in agonizing slow motion.
Right. Data starts getting silently truncated, customer profiles get overwritten with null values. You don't even realize the integration is broken until the partner's legal team calls you 3 weeks later.
Which is why the workflow here flips the script. Before you let the AI touch the core integration logic, you demand it builds the guardrails.
Okay, what does that look like?
You research the partner's API limits. You plan the telemetry. You build aggressive logging and validation checks first. The guardrails are there to catch the slow motion failure the second the AI tries to pass an invalid data type.
You build the cage before you let the monster out.
Exactly.
I'm entirely sold on the research plan build discipline. But, I mean, if this rigorous workflow is the only way to survive production, why is the entire tech industry currently obsessed with leaderboards?
Oh, the leaderboards.
Everyone is staring at SWE Bench Pro from Scale, watching tools like Augment's Augie top the charts, and they're all pretending the problem is just magically solved.
Because the industry is hopelessly addicted to a single digestible score.
Yeah.
Benchmarks like SW Bench Pro are really valuable academic signals for evaluating raw model capability. But relying on them for enterprise strategy is a fatal trap.
Why is that? I mean, a high score means it writes good code, right?
A high score means it writes good code inside a pristine, highly scaffolded testing environment where the context is perfectly fed to the agent.
Not reality.
No. A benchmark cannot replicate the messy, undocumented, decade-old spaghetti logic of your specific company.
Right.
An AI that scores 100% on a leaderboard will still confidently destroy your payment pipeline if it doesn't understand your unique business constraints. You absolutely cannot benchmark your way out of human governance.
It just provides a false sense of security while entirely distracting leadership from the actual financial reality of AI coding.
Which brings us to the economics.
Yeah, the pricing models tell the real story here.
How so?
Well, you have standard seat subscriptions for basic autocomplete, but when you move to the heavy, autonomous agents like what you see with Cursor's premium tiers, you enter usage-based or token-based pricing.
Which gets expensive.
It does, but the vendor cost is just a fraction of the equation. The hard truth for any business listener today is a fundamental shift in capital allocation.
What's the shift?
AI reduces the cost of writing code to near zero, but it massively inflates the cost of verifying code. Because reviewing 10,000 lines of plausible, subtly flawed machine code takes exponentially more senior engineering hours than just writing 1,000 lines from scratch.
Exactly. If you are an executive and you don't aggressively reallocate your budget away from pure production and into robust verification workflows, you aren't saving money.
You're just putting it on a credit card.
You're deferring a massive, high-interest loan that the market will eventually force you to pay back.
Okay, let's synthesize this into a battle plan. If you're listening to this deep dive on your commute and you have to walk into a board meeting tomorrow to defend your AI engineering strategy, here is the calm, repeatable talk track.
Take notes.
First, ground the room in reality. AI provides incredible velocity, but it manufactures subtle errors at an unprecedented scale. Second, redefine the metrics. Stone celebrating raw output volume and make the reduction of comprehension debt a core KPI.
Love that.
Third, enforce the discipline. Mandate a strict research plan build workflow for all autonomous agents. And finally, harden the perimeter. Treat every AI commit as a potential security risk, because the cost of leaked secrets is existential.
That is exactly how you strip away the magical thinking and actually lead an engineering organization into the next decade.
Yeah.
But, I want to leave you with one chilling, overarching thought.
Oh boy, lay it on us.
We talked about how fast comprehension debt is accumulating today. Think about the trajectory. If human engineers are increasingly relying on AI just to explain the undocumented legacy code that previous generations of AI wrote, what happens to the human loop in 10 or 15 years, when the original human developers are completely gone and we're left with systems built on top of endless layers of machine translation, are we enthusiastically building a digital infrastructure that literally no human mind is capable of understanding?
Thanks for listening to the Reflect Podcast, where we're telling the future. Are you in it? Visit reflectpodcast.com and share your story.
In the cyber ocean of online voices and recycled content, something different has arrived. Reflect isn't just another podcast, it's the future of storytelling, powered entirely by AI. From curating data to assembling thought-provoking ideas, we've redefined how journeys are told. Reflect is a podcast that thinks, learns, and evolves with each episode. Every tale, every insight, crafted by the most advanced AI technologies. A podcast that disrupts the industry, breaking free from traditional formats, taking you on an entirely new experience. So tune in now and reflect. We're telling the future.